So we have a small object with a mass of 250 grams is placed at the top of a frictionless circular track. So basically your track would be something like this. You will imagine it to be so. So where is it? And this radius is 40 centimeter. Okay, this is a toy track thingy. 40 centimeter or 4.4 meters. For what minimum height above the lowest point? So this is the lowest point. So at what height? Where is that? For what minimum height above the lowest point of the track must the object be released so that it successfully completes the loop without losing contact with the track? So somewhere over here, if I leave, the object goes in this manner and it keeps going. Okay, so that's the question. So how do we go about solving this? Well, we know for anything to go in a loop, we have certain condition that has to be met at the top and the bottom and everything. So with that knowledge, with the knowledge of energy, conservation of energy, this is a small topic from your previous grade, and we're going to learn in detail in the next set of chapters as well. So we have to make use of that. So first thing is, what will I do is, I'll figure out, moving away from the exact question, I'll just figure out what should be the velocity at the peak. So at top of the loop, the object must have a minimum speed, right? The object must have a minimum speed. So that would be mv square by r for it to counter mg, right? And so your velocity will be root of how much is that? 40.4, sorry, 4 basically 2 meter per second, right? So that would be our velocity that we need. Now we are using energy conservation concept. So some point P, which is at a height of h, that energy has to match the energy that the object has at the top. So the object's energy at P with a height of h has to match the object's energy at the top. So we have to figure out this height. Okay, so basically your initial, it doesn't have any kinetic energy, we just have potential energy. So if this is a bit confusing, you will understand this in the next chapter better. But yeah, this is something that you should have learned by now. You have learned by now, sorry, you have learned by now actually. So mgh should be equal to mg, potential energy at the top is 2r, the radius, and half m, the velocity at the top, or vh, whatever I have taken it as. Okay, not written anything, I'll write as vh. No confusion, let me write h itself. So everywhere we have the mass, that to be ignored. This is 10, this is h, this is what is radius? 0.448 plus half, this is 4, 1s are 2s are. So h is equal to 10, 10 by 10 is 1 meter. So if I leave an object at a height of 1 meter over here, okay, this height, not exactly over there, but This entire thing is 0.8 meters, but we need to leave it somewhere over here so that it falls, and yeah, that is a bit weird scenario. So yeah, the framing of the question could have been better, could have been well thought of actually. Actually, this comes from, let me make it clear. See guys, this comes from this track that you will study in your work energy concept thingy. So we have to leave it over here. It'll gain some energy and it'll go the loop the loop, and then it will exit. So for that, this is the answer.